Good morning, everyone. So, this is lesson 5.1 on asymptotes, vertical, horizontal, and we're going to deal with holes. So, for asymptotes, what are they? Asymptotes are where a line never gets to, wherever the line seems to be approaching but never gets to. So, let's say along this line here, this would be a vertical asymptote, right? Vertical asymptote. Because, well, this line is going up and up and up, and it never seems to get here to this vertical asymptote. And similarly, we have a horizontal asymptote here, where again, this line wants to approach it, it's approaching it, but it never seems to get to the asymptote. So those are vertical and horizontal asymptotes. But what are holes? Holes are a little bit different, such that there is a blank portion within the line. So let's say that this portion didn't have anything in it. That would be a hole. Now, basically, it's a break in the function. So here is a hole, and it is a break, a missing point in the function. And holes happen when you have a function, like let's say you had y is equal to 2x plus 1 times 3x plus 5 over 2x plus 1. Well, these two cancel. And whenever you have something canceling on the top and the bottom, it creates a hole, it creates a missing piece for the y function. So this function is going to have a missing piece at 2x plus 1 equals 0. So it's going to have a missing piece at x equals, if you bring the 1 over, it becomes a negative 1. And if you divide by 2, you get negative 1/2. So we'll have a break when x is negative 1/2. All right, number 1. Number 1 says the vertical asymptote is x is negative, find the vertical asymptote. Now, to find the vertical asymptote, we must ask ourselves, what can this function approach but not be? What can it not be? What makes this y equals infinity? That's for the vertical. That's what we have to ask ourselves. What would make y equal to infinity? Remember, f of x is our y. So I know if y is equal to something, right? Let's say it was x minus 4 over 0. Do you know what 10 over 0 equals? That means out of 0 slices of pizza, you get 10. It means you're literally God, right? It means you can make something from absolutely nothing. you can dig into your pocket and pull out a box of pizza, right? So this is infinity. Okay? When you have something divided by 0, it's infinity. So how can we represent infinity? When you look at a graph, infinity, right? This is y is negative. This is like y is negative 2, and y is 2, and then all the way up here is infinity. So how can we make this jump to infinity? That would be our vertical asymptote. Something that you can never get to. No function. It's going to approach infinity, but no function will really get there. So this is going to be our vertical asymptote. Now, how can we make x minus 4 equal 0? Well, x plus 4 equals 0 when x is negative 4. So we have a vertical asymptote at x is negative 4. So that would be, we would have a vertical asymptote here at when x is negative 4. Okay. So your function would look something like, this is x minus 4. Does this have a horizontal asymptote? It does. Okay, we'll get into that later. Number 2 says, the vertical asymptote of the function below, find it, right? So y is x minus 6 over x squared minus 6x. Again, the question, right, we're trying to get to x minus 6 over 0. How can we make this equal to 0? Because this would make infinity, and that would be our vertical asymptote. Okay, so x squared minus 6x is 0. By factoring, we would get, if we look at what's in common, they both have an x. Let's take out an x, and we get x minus 6 is 0. Now this is easy, because you're dealing with factors, meaning they're multiplying. You could use the ZPP rule. Gee, if this was 0, then it would check out, because 0 times anything is 0. So x is 0. Gee, if this was 0, that would be great, because then this times anything will be 0. So that would work too. Now, we might think that this is a 0. However, when you plug this in, what do we get? Y, remember our function, y is x minus 6 over this piece here, right? Which is this right here. If we plug that in, we notice these are the same. So they cancel out, and that is the whole that we're talking about. There's actually a whole at x equals 6. And the only thing that's left over is the x. So for this to be 0, x must be 0. this is your answer. That is your vertical asymptote, because this was a hole, because they canceled out. If they cancel out, that's where your hole is going to be. All right, number 3. Find the vertical asymptote of the function. We have y is, and we have x squared minus 4x minus 5 over 2x plus 2. We want to get the vertical asymptote, which means we need this equal to 0. 2x plus 2 is 0. We're going to move the 2 over. We get 2x is negative 2. We're going to divide by 2, and we get x is negative 1. So this is your vertical asymptote. And that's going to look like, here's x is negative 1. That is your vertical asymptote. Okay? Says, oh my God. Guys, forgive me on this one. It would be your vertical asymptote, except I goofed up. We got to factor this one first to see, just in case, if it's a hole. So don't do my mistake. Remember, this is a times c up here. So this is your a value and your c value. Remember that for a quadratic. And this is your b value here. And so 1 and 5 make 5. And for it to be negative 4, the 5 must be negative. So up on top we have x plus 1 and x minus 5. And down below we have 2 times x plus 1, if you factor out the 2. And so this is your whole, actually. And what's remaining has no x's and no way of being 0. So therefore, the vertical asymptote is none. Right? Does not exist. Number 4. Number 4 says, find the horizontal asymptote of the function below. Now, for the horizontal asymptote, we need to take a ratio between the highest degrees, meaning the coefficients is going to be the leading coefficient of the top one over the leading coefficient of the bottom one, meaning 1 over 1. So the horizontal asymptote is 1 over 1, which is 1. That is the horizontal asymptote. So this is y equals 1. Right? For it to be horizontal, we need to be talking about the y. Right? If we were talking about the x, right, let's say x was 2, then it would be vertical, as you can see. But we're talking about instead y is 1. So y is 1 is here. That's a height of 1. And the height of 1 continues. All of these are examples of heights of 1. This is your asymptote. This is something that graph can't achieve. So an example, I'm not sure if this is accurate, but that could be an example. That could be an instance of a horizontal asymptote. just like that. It approaches it, but it never gets to it. Number 5. Find the horizontal asymptote of x minus 6 over x squared minus 6x. Again, I want to factor, just in case there's anything that cancels and there are wholes. And there is, they do. So we're left with 1 over x. There's a hole here. This is a hole at x is 6. But they're asking about the horizontal asymptote, which occurs with a ratio. Now remember, if there's no x value there, then this is plus 0x. So the ratio between 1 and 0, right, you get 0 over 1, which is 0. So this is your horizontal asymptote. Right? You do the leading coefficient over the leading coefficient of the bottom. The top or over the bottom. So you did this one over this one. Now, the leading coefficient of the bottom one was x. On the top one, we didn't have an x. So we made one up, right? Remember, if you don't have one, it's okay to put 0 because 0 times anything is 0. So you're not really adding anything. Number 6. Which function? Let me just see this. It says, which function doesn't have a horizontal asymptote? Well, horizontal asymptotes occur they cannot occur if the top leading coefficient is bigger. Right? It has a bigger leading coefficient. For example, if the ratio of leading coefficients was that the LC over LC, the top one was 2 and the bottom one was 1, then it cannot occur. Sorry, 2 over 0 cannot occur because this is infinity. Okay, and then that would let you know that you have a 0 on the bottom. This is a vertical asymptote. So that would imply that you don't have a horizontal asymptote. Okay. Just know this. Know this. I'm going to just do the case. Okay. The case is you have a function p of x over q of x, right? And if p, right, I could just simplify as p over q. How about that? If p, the degree, right? We're talking about degree. If the degree of p is greater than the degree of q, then there's no horizontal asymptote. If the degree of p is less than the degree of q, then we have y is 0. And if the degree of p is equal to the degree of q, then we have the ratio. Right? The leading coefficient of p or the leading coefficient of q. All right. Let's just kind of prove this a little bit. So let's say we have our previous example. in our previous example, we had 0x over 1x, right? Let's make it more simple. We had 1 over x. Now, the leading coefficient on the top is, on the one on the bottom is bigger. So according to this, you do not have a horizontal asymptote, right? Because here, this one, Q is bigger than P. Oh my gosh, did I just say that wrong? All right, again, Q is bigger than P. It's right here. Sorry, I'm kind of off today. Horizontal asymptote is here, 0. And as you can see, Q is bigger than P. And same here, Q is bigger than P. So horizontal asymptote is 0. And then here, let's say that P is bigger than Q, so let's just say x over 1. This would be an example where P is bigger than Q, and so you don't have a horizontal asymptote. And then here, let's say that P is equal to Q. So let's say you have x over x. Well, then this is, P equals Q for the degree. And so you would have a ratio, 1 over 1. But let's say you did a ratio here. This is what I really want to show you. Let's say I did a ratio for this one. Would I still get y is 0? Let's see. If I did 0x plus 1 over 1x, what is 0 over 1? That is 0. So that works. What about this one? What is, let's say we have x over 0x plus 1. Well, 1 over 0 is infinity. And as you know, you can't have infinity as an answer, right? The y would go to infinity. That goes to y. Y goes to infinity. And that is a vertical. That is a vertical asymptote. Okay? Okay. It wouldn't make sense for y to be infinity. Right? Horizontal asymptotes are either 0 or a ratio, not infinity. So in this case, just know that if P is bigger than Q, you have none. Okay? Okay. Number 7, it says find the whole of the function. Oh, these are easy peasy. X minus 4 over x plus 4. Well, you're going to have x if nothing cancels out here. So there's no whole. right? Nothing cancels. No whole. Number 8. The function says find the whole, okay? Okay. Now, for the top portion, we're going to have -5, right? This is A times C. For the top portion is -5. 1 times -5. And then the B value is -4. So again, 1 times 5. And we have I think we already did this one. If you factor out a 2, here's the whole, because they cancel. So they have a whole at x plus 1 is 0, and x is -1. That's where your whole is at. Number 9. Number 9 says, find the x and y intercept, write your answers. Okay. All right, these are fun. Find the x and y intercept. So the x-intercept happens when y is 0. So y is x minus 4 over, right? Y is 0. And how can you make this 0? Well, that only happens if this was 0. X minus 4 is 0. So then x is 4. This is your x-intercept. All right. Similarly, we could do something like this for this one. Or actually, sorry. The y-intercept happens when x is 0. So y is 0 minus 4 over 0 plus 4, which is -1. So there you have it. Y-intercept is at 0, -1, and the x is 4, 0. Number 10. Find the x-intercept. Okay. I think you guys are capable of number 10. Find the y-intercept. So number 10 and 11 are the same. Okay. Awesome, you guys. Thank you for watching. As always, you can fast forward through the video. I know that some of these parts were slow. A big highlight would be this one. Big highlight. Okay. And again, if y was infinity, it just doesn't make sense to have a horizontal asymptote at infinity. So that's when you have no horizontal asymptote. You cannot have a horizontal asymptote at infinity. You can have a vertical asymptote where the graph goes to infinity at that point, right? But it doesn't make sense to have a horizontal asymptote. I can't even get to infinity, first of all. And then to have a horizontal asymptote at infinity is really ridiculous, because you can't get there, and then you're saying that it just keeps going this way. Maybe a radical function, but that is never used, and So we just say that it doesn't, right? This is super theoretical. So no horizontal asymptote when the ratio is infinite. And it's infinite if you have something over 0, right? 1 over 0, 10 over 0. That's going to go to infinity. So we're going to say that's no, right? But if that ratio was 0 over 1, then yeah, you got a horizontal asymptote at 0. And if the degrees were the same to begin with, you do the same thing. You do a ratio again. So these are just ratios along with logic. You're not going to have a horizontal asymptote at infinity. And if you don't have an x term here, you do a plus 0x. And you do a ratio between this leading coefficient, the biggest leading coefficient in total, which is this one. Biggest, the degree, so you go with the degree that's the largest and look at that leading coefficient. And if this one doesn't have it, you make it so that you can match, apples to apples, right? If we're talking about degree of x, degree of 1, right? Degree of 1, then you got to you got to compare it to another degree of 1. And in this case, we didn't have it, so we made it, right? 0x. Okay, that's all, guys. Thank you for watching, and take care.